Hello, hello, hello! I would say welcome back, but I imagine for a lot of you watching this video, this will be the first time you've seen me, so instead I'll just say welcome. My name's Patrick. I am a professional tutor, and mainly on this channel, I've been doing university admissions and A-level work slash IB work, but I also have some GCSE math students, and so I thought I would do some live solves of that as well in case you find that helpful. So today I'm going to be doing a live solve of the Edexcel iGCSE. This will also, obviously, because math is math at a certain point, so the stuff will still be relevant if you're doing other syllabuses. It's just that the iGCSE has some stuff in it which is specific only to that board. So as we're going through, I'll point out if that's specific to that board so you don't sort of freak out if you don't actually need it. But the main reason why I've been doing these runs is because teachers in a classroom only really have enough time to teach you the material, but you never really get someone necessarily teaching you exam technique. And so I found myself telling people how to do things, telling people how to check their work. And I've started this here to instead demonstrate it. So you can kind of see the techniques in action, see how you can check your work in order to pick up on those small execution errors and make sure you get all the marks you deserve. So without further ado, I think we're gonna just jump straight into it, just so you can see what I mean. So I will time it, but I imagine this will be a lot quicker today. So I should have 2 hours on the clock, and I can set a timer for that, although I imagine I will not need that. And I'll be annotating direct onto the paper, and then marking it at the end. Now, the most important thing you're going to want to check for is how I check my work. And I do have a calculator emulator that I can pull up, so I can show you exactly what I'm typing in. Now, when I'm doing it for the first time, I imagine I won't necessarily show every step of the pressing the buttons because that typically isn't the most complicated part. But when I'm checking, I think that's when I really want you to see how I'm typing things in. So at that point, I'll bring the calculator in, show you exactly what I'm typing in, and hopefully that will be helpful for you. So let me just get everything up and running. We're going to share the window with the paper on it. There you go. And I'm just going to get into it. Now, this is completely sight unseen. I have no idea what's coming up, but I'll kind of just commentate on what I see as we go through. So without further ado, let's get into it. Question 1. So here we have an arithmetic sequence. Find an expression in terms of n for the nth term. Now, I have a fun little way that I like to do this. So typically, we talk about getting from term to term. That's 3, which means it would be 3n. Now, my way of getting what the sort of to add or subtract to that, you track back from that and think, what would the term before this be? So to go from here to here, I would subtract 3 to 1. Then from here to here, I would subtract 3 to minus 2. And so it's 3n minus 2. That's 1a. Now, the nth term of a different arithmetic sequence is 5n plus 17. Find the 12th term. The important thing to know here is n represents which term I want to find. So if I want the 12th term, I want to substitute 12 for n. So that will be 5 into 12 plus 17, which you just type into your, well, to be honest, 5 times 12 is 60, plus 17, which is 77. But again, in an exam situation, I would also type it out, even though I'm confident with my mental math, just to make sure I didn't make a small execution error. Question 2. We have 450 students asked how they travel to school on a Monday. Walk, bus, car, bike. These are probabilities. Work out how many traveled by car. Okay, so this at first glance might look a bit tricky, but then you remember that these are all probabilities. Then you remember the sum of the probabilities must be 1. So adding this all together, we get that 3x plus 0.46 is equal to 1. And you can't see that. That is unhelpful. Let me zoom out. Not zoom out, but let me scroll down just a touch. Nope. There we go. So And in fact, let me also write that over here so we have a little bit more room. So we've got that 3x plus 0.46 is equal to 1. And then 1 minus 0.46 is 0.54. So 3x equals 0.54, and x is equal to 0.18. Now, we're not done yet. The second you think you're done with the question, reread the question to make sure you've got over the finish line, because it's very tempting to go, I found x, and think you're done. You're not done, because x is just that probability. It wants to know how many of the 450 students traveled by car. So the probability of traveling by car was 2x. So the probability of car is equal to 0.36. And then you can do the 0.36 times the 450 to work out that number of students. So 0.36 times 450 is equal to, in fact, let me put my working. Always, always, always show your working. But that is equal to, let me just scroll down so you can see this, 162. And I'll double underline to say that's my answer. Okay. That was quite a lot. Yeah, 4 marks. Okay. So then question 3 here. Find the highest common factor of these two. Show your working clearly. When they say show your working clearly, that is just to say that you cannot use a special function on your calculator. So they want to see the steps. So what I'm going to do here is find the prime factorization of 72 and of 108. So 72 I know is 12 times 6, 3 times 4, 2 and 3, 2 and 2. So 72 is 2 cubed times 3 squared. And 108 is 12 times 9, which again is 12 is 3 and 4, 9 is 3 and 3, and that 4 is 2 and 2. So that is 2 squared times 3 cubed. Now the highest common factor is going to be all of the prime factors that are common to both. So 2 is common to both, 3 is common to both, and for the highest common factor, we want all of those to their lowest power present. So here I have an option of a 2 or a 3. The lower of those is 2. Here I have 3 to the power of 2 and 3 to the power of 3. The lowest power available is 2. So my highest common factor is 4 times 9, which is 36. Which I should, by the way, really be writing in the answer key as well, just for good technique. In fact, let me scroll up and make sure I've been doing that. I've not been doing that. So 162 should go on that answer line. And 77 should go on this answer line. So I'll go through and make sure I'm doing that as we move forward. Okay, so question 4. Ava records the number of kilometers she drives each month. In April, she drove 943, which is 15% more than she drove in March. So 943, 15% more. You have to remember there's this kind of scale multiplier. 1 plus p over 100. This comes up in compound interest, but it also comes up in percentage change. So that here would mean 1.15, because it's 1 plus 15 over 100 is the multiplier. So 943 is equal to 1.15 times the number she drove in March. So to get the number she drove in March, I'm going to do 943 divided by 1.15, which gives me 820, which is my answer. Okay. So in the diagram, so this looks like regular polygons and internal and external angles. So this is a regular pentagon. Work out the size of FED. Okay. Well, let's work out the internal angles of a regular pentagon. To do this, I actually don't, a lot of people want to go by the sum of the internal angles and say that the sum of the internal angles is equal to n minus 2 lots of 180, which here would be 5 minus 2 is 3 times 180, which would be 540. And then they like to divide the 540 by 5 to make 108. I actually don't like that as much. I much prefer going via the external angle. So the external angle is given by 360 divided by n, which here is 5. So 360 over 5 is equal to 72. And then the internal angle is 180 minus the external angle. So that's 180 minus the 72, which also gets me my 108 for the internal angle. The reason I like doing it by this method is you tend to be working with smaller numbers. Like once you get up to 12-sided shapes, the sum is just huge, right? As opposed to doing 360 over 12 is just 30, so then the internal becomes 150. So I like that route, and I encourage you to use that route. But the point is, we now have the internal angle of 108, and that's 96. The sum of all of the angles around a point is 360. So I'm now going to do 360 minus 96 minus 108. And I'm going to get an answer of 156. Now, in the real thing, I don't recommend cluttering all your working up here, but it's just for ease of presentation that I'm going to just sort of write where I find the space. So I encourage you to sort of work on your presentation, use this sort of vast empty space that you have here, laying your work out nice and clear in columns. Don't sort of write all over the middle, because then if you get it wrong, you have to cross it off. Then you're kind of working on the boundaries. Do it nice and sort of clear on the left-hand side. If you make a mistake, single line through, rewrite stuff in the space you've left yourself on the right. So here, question 6, expand and simplify. We're going to use FOIL. So m squared minus 8m from the outsides plus 5m from the insides minus 40 for the last terms gives you m squared minus 3m minus 40. Here, solve this. First thing you want to do is to get everything on one line. So you can do that by multiplying both sides of the equation by 3. On the left-hand side, that would give me 9n minus 12. And on the right-hand side, multiplying by 3 will get rid of that fraction. So it will equal 5n plus 6. The next step is always to get all of the n's on one side and all the numbers to the other. So here I'm going to subtract the 5n to the left to make 4n, and I'm going to add the 12 to the other side to make 18. So that way n is going to be equal to 18 over 4, which is equal to 9 over 2. And I should, again, I'm just forgetting to go across and put them on the answer line. So I'll go ahead and do that now. And then, so n here, sorry, n is equal to 9 over 2. Right, so question 7. This looks like Venn diagrams immediately. So we're going to list the members of the set of B union C. So B union C means anything that is B or anything that is in C. So out of this universal set, B union C would have all the ones in B and also all of the ones in C, which are the multiples of 3. So we also add on to that the 24, the 27, the 30, and the 33. That's everything in B unified with everything that's in C for this set. I cannot be bothered to rewrite that here. Just assume I have rewritten that here. Not A intersected with C. So not A intersection C. So intersections are more exclusions, right? So not A would be the set of the odd numbers. It would be 23, 25, 27, 29, 31, 33. And the intersection of that with C, which are the multiples of 3, means we want to only pick the ones that are also multiples of 3. So it's an exclusive. It's and. It has to be not even, and it has to be multiple of 3. So in this case, the answer would be 27 and 33. Is it true that B intersection C is 0? It is true that B intersection C is 0 because there are no numbers that are both in B and multiples of 3, because none of these 3 numbers are multiples of 3. So there's no element that is in both B and in C. And so that is true. Also, I'll just say 23, 29, 31. I'll say that none of 23, 29, or 31 are divisible by 3. I hate when you have to write sentences, but I know. So the set D has 4 members, such that D intersected with union of A and C is the 0 set. List the members of set D. So basically there are no... If it is in A union C, then it is not in D. So let me find A union C. A union C are the even numbers and the multiples of 3. So the this set would be 24, 26, 27, 28, 30, 32, 33, 34. Because these are all the even numbers. One thing I like to do, by the way, if you struggle with this, because a lot of people struggle with the unions and intersections. Let me show you how you would do this kind of on a Venn diagram. So if I had my 3 circles, although I shouldn't really have 3 if there's no overlaps, but I'll call that A, B, and C. B has only odd numbers, so there's nothing between... Oh, these are all just different. Okay, this is not a great... Okay, I won't do it on a Venn diagram. What I will do is say, if we look at this universal set, to do A union C, you can I use an underlining method. So anything that's in A, we can underline all the even numbers, and we can underline anything that is in C, so all the multiples of 3. So 24, 27, 30, 33. Union would be all the numbers that are underlined. So the 24, 26, 27, 28, 30, 32, 33, 34. A intersection C would be all the numbers that are underlined twice. So the 24 and the 30. And this underlining method can be used in any sort of set theory, with or without a Venn diagram. So for instance, that B union C, I can underline all the elements that are in B, and I can underline all the elements that are in C. And that's how I got this. For the intersection of B and C, we can see that it is 0 because there's nothing that's underlined twice. So that's when I'm teaching this, that underlining method is what I go for. But obviously in the real thing, you go for whatever method best suits you and what you can do. So anyway, here, A union C. Let's go back and redo that. So A is all the even numbers. C is all the multiples of 3. And D has 4 elements and has no intersection with these. So it must be the remaining 4. It must be the 23, 25, 29, and 31. So 23, 25, 29, 31. I know a lot of people struggle with set theory, so I'm surprised to see that so early in the paper. In the real thing, if you struggle on a question, best advice is just leave it and come back to it. So a cylinder is placed on a table. We have a volume. We have a force, precious force over it. You see, this is much easier. What you're meant to get here is the volume of a prism is the cross-sectional area times the height. So in other words, the 157 or 1,575, that volume is this area times 21. And so the cross-sectional area is 150, well, that number divided by 21. And by the way, just for in the interest of gaining method marks, I would always write out explicitly what you are. Basically, if you type it into your calculator, no, I hate the divide sign. If you type it into your calculator, write it on the page, because that way you can pick up method marks in case you type something in wrong. So A is 75. So the pressure is equal to the force of 84 all over the area of 75. Hello, hello. Apologies, I'm just doing GCSE today. Time is of the essence today, and so I'm doing something a bit simpler. So it's 1.12, but exam technique is exam technique. Cool. So here, question 9. Table gives the amount of rice produced by each of 2 countries in 2020. Write that as an ordinary number. That's 3, 5. Oh, man. 1, 2, 3, 4, 5, 6. Because then it's then the 3 is in the 10 to the 7 position. So that's 10 to the 1, 2, 3, 4, 5, 6, 7. In Japan, work out the amount of produced that many more tons of rice than Argentina. Work it out in standard form. Well, this is 6.78 times 10 to the 1, 2, 3, 4, 5, 6. So Japan produced that many more tons of rice than Argentina. So it's 8.2 times 10 to the 5 plus 6.78 times 10 to the 6. Argentina, catch up. And I can type that direct into my calculator, actually. And say 8.2 times 10 to the 5 plus 6.78 times 10 to the 6, and get an answer of 7.6 times 10 to the 6. Which I'm going to write here on the answer line. Question 10. Simplify this. Well, anything to the power... In fact, let me zoom in a little bit. Anything to the power of 0 is equal to 1. So that's what I'm writing on the answer line. Here, this is power laws. So when you multiply things to the same base, the powers add. So I can simplify the left-hand side as y to the 6 equals y to the n. So n is just equal to 6. Simplify fully here. You need to know that the power goes on everything in the bracket. So that is the same as 5 cubed times a to the 4 cubed times c squared cubed. And you need to know that when you are, the power law you need to know is anything x to the a raised to the power of b, you multiply the powers. So here that would be 125 from the 5 cubed, a to the 12, c to the 6. And I'm going to write that, just for good technique, on the answer line. So 125, a 12, c6. Okay, so that's there now. Okay, so we have a roof support for question 11. I see this and immediately think these are the same length. I'm going to write this stuff on the diagram to help me out. So AC is equal to 9, BC equals 9, AB equals 12. That's 90 degrees. That is the roof support. It's made from 4 lengths of wood, so we need all of these lengths of wood. Wood costs this much per meter. And you need to buy a whole number of meters. So we need to work out the length of this thing. Well, if that's the same, that's going to cut this in half. So each of these would be 6. The idea here is we have to use Pythagoras to work out the length cm. So cm squared plus 6 squared equals 9 squared. So cm squared plus 36 equals 81. Cm squared is equal to 81 minus 36. And at GCSE, I would show every single step, which is 45. So Cm is equal to the square root of 45, which is 3 root 5. And so the total amount of wood is going to be given by the 9 plus the 9 plus the 12 plus that 3 root 5. And that is going to be, well, 9 plus 9 is 18, plus 12 is going to give me 30. So that's 30 plus 3 root 5, which is 36.7 meters. Therefore, they have to buy 37 meters. And if each meter of wood is 2150, then I have to do 37 times the 2150 in order to work out the total cost. So 37 times 2150 gives me an answer of 795.5 euros. Okay. So factorize fully. Ooh, okay. Okay. So can your calculator do this? Yes. Am I going to get my calculator to do this? No. What I'm going to do instead is remember how to factorize when there's a number in front of the x squared, or when a is bigger than 1. So in this case, I multiply the front number and the back number, and I get a target number of minus 24. So I'm looking for numbers that multiply to minus 24 and that add to minus 5. So that's going to be minus 8 and plus 3. So then I can rewrite my minus 5 as 6y squared minus 8y plus 3y minus 4. And then factorize in pairs. So from the first pair, I can take out a 2y and be left with a 3y minus 4. And from the second, I just have one lot of 3y minus 4, because I'm wanting these two brackets to be the same. From there, I can take that bracket out as a common factor and be left with 2y plus 1 into 3y minus 4. And that is fully factorized. Then from B, express this as a single fraction in its simplest form. The trick here is to get things to the lowest common denominator. A common mistake I would see people make here is to multiply these two things together to say it would be 12x squared. That is not the lowest common denominator. Because, for instance, if you were doing a half plus a quarter, you wouldn't say the common denominator was 8. You would say it is 4. And so actually, the lowest common denominator between these two is going to be 12x, not 12x squared. So I can make my life easy by not multiplying by that second x. So I'm going to multiply everything here by 3 and make it 6x plus 3 over 12x. And the second one, I'm going to multiply by 4 to make it 28 minus 20x all over 12x. And then when I combine those, you combine the like terms and say the 3 plus the 28 is going to be 31. 6x minus 20x is minus 14x all over 12x. And that is it in simplest form. Can't even see the answer line. Let me zoom out for a bit, just to whoop. So 31 minus 14x all over 12x. Okay. Right, so moving on to 13. So we have a tree diagram. So in bag A, there are 3 white beads and 7 black beads, so 10 beads in total. That means the probability of getting white is the 3 white out of the 10 total, and black would be 7 black out of the 10 total. Then for bag B, there are 9 beads in total, so getting white would be 5 out of 9, and getting black would be 4 out of 9. And I'll write those probabilities on all the necessary lines here. And that solves A. B is work out the probability that someone takes 2 beads of the same color. So that is the probability of getting 2 whites or getting 2 blacks. And the or means you add the probabilities together. So the probability of 2 whites is white on the first, which is 3/10, and you get a white on the second, and that and means you multiply. Or you get a black on the first and a black on the second. So you'll notice how it's and means times and or means plus. So you get 15 out of 90 plus 28 out of 90. And 15 plus 28 is 43, which I will put on the answer line. So moving on to question 14. We have combined savings of 15,435. Bahira's are 45% more than Abel's. So we can work on that first. So we saw that before with the sort of multiplier. 1 plus p over 100 means that that multiplier is 1.45. 1 plus 45 over 100. So what that means is, let's translate, and whenever you're forming equations from a question, the trick is to translate the English into the math. So the savings of Bahira I would call B. R equals 45% more, 1.45, times A. And we have that A plus B is 15,435. This gives me simultaneous equations. So I can plug that B in here and get A plus 1.45A equals 15,435, which means that 2.45A is 15,435. So A is 15,435 divided by 2.45, which I am not good enough to do in my head. And so I will 15,435 divided by 2.45 gets me that A is equal to 6,300. And B is equal to 15,435 minus 6,300, which I can run in my calculator. 15,435 minus 6,300 is equal to 9,135. So I found my A and my B. Now the savings of B are 1.5 times, and in fact I can translate that into math as well. B is equal to 1.5 times the savings of C. So the savings of C is B over 1.5. And I know now that B is 9,135. So it's 9,135 over 1.5, which is 6,090. And that is my answer. Okay. So question F, we have a function. State the value of x that cannot be included. There are two ways to not be included in the domain. One is to cause a divide by zero error, and the second is to cause a square root of a negative number error. So to avoid these errors, in this case, we have no square roots, but we could end up with a divide by zero error if x was equal to 2. So that cannot be included. This is 3 marks. There's something technical about this in A level that I would comment on, but this is GCSE, so I won't. The inverse, you write, well, you have your original equation, y equals 3x plus 1 over x minus 2. Actually, I will get, for the iGCSE, I will comment on this at the end, but this is iGCSE only once you get to the end. In general, to find inverse functions, you swap round your x and y. So x is equal to 3y plus 1 all over y minus 2. And I'm going to make y the subject of that new equation. So we're going to multiply both sides by y minus 2 and say that xy minus 2x is equal to 3y plus 1. Then you want to get all of your y's on one side and everything else to the other. So I'm going to say xy minus 3y by subtracting that across is equal to, and adding the 2x across, you get 2x plus 1. Hello, Vivan. Yes, early stream. Weird block in my calendar. I thought I'd fill one in. So then we factorize out the y and say y into x minus 3 is equal to 2x plus 1. And then you divide both sides by the x minus 3, and that is your answer. I will point out two things. One, I've seen very difficult inverse functions on iGCSE papers where you have to find the inverse of a quadratic function. In order to do that, you have to complete the square on the quadratic and rearrange it to make x the subject. Now, I will also point out that sometimes when you're doing the inverse, they want you to talk about the domain and range. They didn't do that here, but when they do want that, you need to know that the domain and the range swap round. So the domain of the original is the range of the inverse. The range of the original is the domain of the inverse. So if they had asked me about the range in part A, they might expect me to say that therefore the domain of the inverse in B is the same as the range in A. Didn't happen here because it was earlier in the paper, but if this happened as like a final question, I might expect that to come up. But again, everything I've said there about the inverse of a quadratic and domain and range is something I would expect for iGCSE only. Now here for question 16, we seem to have another probability question. 20 sweets in a box. I think this one will be without replacement. So 15 red, 5 yellow takes at random 3 sweets. Find the probability that he takes at least one of each color. Now that's going to be kind of complicated because, well, let's put it this way. There's two ways of doing this one. Either we do it directly, where we get the probability. Now, because he's taking 3 sweets, that's either red, red, yellow, and all combinations of that. So it's either red, red, yellow, red, yellow, red, or yellow, red, red, which will all have the same probability. So you would do 3 lots of that. Or 3 lots of yellow, yellow, red. Where it might be complicated to remember to multiply by 3, because here, again, there's different combinations. There's yellow, yellow, red, red, yellow, red, yellow, yellow. So there's kind of 6 possible outcomes to include in here. And I'll show you this first. So that would be 3 times. Red would be 15 out of the 20 available. Once I've taken a red out, there's only 14 reds left out of 19 sweets total. Once I've done that, there are still 5 yellows left out of the 18 remaining sweets. To that, you would add 3 lots of 5 yellows out of 20 total, then 4 yellows left out of 19 total, then 15 reds left out of a total of 18. And we can work these out individually. Now I'm going to show all my steps here. So 15 times 14 times 5 out of 20 times 19 times 18. So that's 3 lots of 35 over 2 to 8 plus 3 lots of, and this time it's 5 times 4 times 15 all over 20 times 19 times 18, which is 5 over 114. So 3 times 35 over 2 to 8 plus 3 times 5 over 114 gets me a probability of 45 over 76. Now, that was a bit complicated, but there was an easier way of doing it, which is harder to spot conceptually, though. Oh, sorry, question. Sorry to distract from the probability question. Curious, How much more difficult are interviews at top colleges such as Trinity College, Cambridge, compared to Pembroke, for example? So, quick break in this. I'll put a timestamp in when I come back to it. I would say if you're talking about Oxford Gentry, um, interviews at Trinity, I would say the interviews, you do not necessarily know how difficult the interviews are going to be. Um, and again, how difficult an interview feels kind of depends on your strengths and weaknesses. The only thing I would say about Trinity in particular, as compared to any other college, is oh no, they might have gotten rid of this. Up until recently, they had an extra test. So I know I had someone get in for chemistry at Trinity. I say chemistry, like obviously natural sciences, but focusing on chemistry as his lead in the ESAT. And Trinity were setting an extra test that you would sit on the day of your interview, and then your interview would be based on your answers to that test. Um, so that would be tricky. But I think they got rid of that, so I think it should be a level playing field. So it's hard to say because like I say, it depends on your strengths and weaknesses, and it depends on who the fellows are at each individual college who set the questions. So hard to give strong advice on that, which in other words means you shouldn't really be factoring that into your choice of college. Your choice of college should be determined by if you get to visit it, where you feel most at home. Because if you don't actually like the college, then it feels like you're living at the office, which is a terrible state of existence. So find a place that feels like home, where you feel comfortable and you want to live for the next 3 or 4 years. That's number 1 on the list. Number 2 on the list is who are the fellows at that college who would be doing your supervisions. And I wouldn't really consider competitiveness unless you have specific things like, I know it's classic that Trinity, people typically think that Trinity and John's aren't good for state schools and that King's isn't good for private schools. I don't know how much I believe that, but yeah. I will say Trinity Engineering, ooh, that was tricky this year. Trinity Engineering was the really tricky interview. What I would say is Trinity, I think, have got rid of their pretest, so they're now in line with everyone else, only doing ESAT. But I think I had one student get in for Trinity Engineering and one got rejected. I think he got in. I'll have to check on that. I'm sure he got in. Thanks for reminding me. I'll check up on that. But right, okay. Side note over. Let me go back to the probability question and show you the second way we could have done this. Because it's actually much easier. It's harder conceptually to spot this, but easier to sort of, if you do spot it, it makes the math easier. That instead of working out the number of ways of at least one of each color, you can instead get rid of ones where they're only one color. So in other words, it's 1 minus the probability of red, 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 minus the probability of yellow, 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 which is, say that 10 times fast. So that actually makes the math easier, because then it's 15 over 20, 14 remaining reds out of 19 remaining sweets, 13 remaining red out of 18 remaining sweets, and minus the 5 out of 20 times the 4 remaining out of 19 remaining times the 3 remaining out of now 18 remaining sweets. And that makes your math a little bit easier. So 15 times 14 times 13 out of 20 times 19 times 18. So it's 1 minus 91 out of 228. Minus, and this one would be 5 times 4 times 3 over 20 times 19 times 18. 1 out of 546. And when I type all this in, apologies that it's not laid out phenomenally, but 1 minus 91 over 228 minus 1 over 546 gives me a different number entirely. Why does it? It shouldn't give me a different number entirely. Please pause while I troubleshoot. No, 1 minus over 20 times 19 times 18. Because it may be that I got the harder one wrong. No, I just typed something in wrong. So let me try. I think the 5 times 4 times 3 when I got wrong 20 times 19 times 18. Yeah, that should have been 1 out of 114. And that's kind of spoilers for the checking, by the way. So 1 minus 91 over 228 minus 1 over 114 does give me the exact same 45 out of 76. So that is the answer. And it goes to show, by the way, even me, like, it's very easy to type things in wrong and get things wrong in the execution, which is why the checking is so important. So coming into here now, question 17. When you have surds like this with a plus or a minus on the bottom, the way you rationalize the denominator is to multiply top and bottom by the bottom with the sign flipped. So in this case, we're going to multiply by 3 plus root 5 on top and bottom. It doesn't matter if the square root is at the front. If that had been root 5 minus 3, I would still just multiply by the sign flipped and make that root 5 plus 3. So then on the top, we're going to FOIL it. We get 1 and 3 makes 3. 1 and root 5 makes root 5. 3 and root 5 makes 3 root 5. Root 5 and root 5 makes plus just 5 by itself. On the bottom, 3 and 3 makes 9. Minus 3 root 5 plus 3 root 5 minus and then 5. Now the point here is that on the bottom, the roots will then cancel. 3 plus 5 is 8. 1 lot of root 5 plus 3 lots of root 5 is 4 lots of root 5. On the bottom, the 9 minus 5 gives me 4, and the square roots here cancel. Now dividing this, you end up getting 2 plus root 5, which is the final answer. Where's my answer line? Oh, they don't have one. Okay, guess that's it. Okay, so here we have a curve. If you are not doing iGCSE, kindly disregard this question. This is an iGCSE only question because it involves differentiation. So here, you differentiate, and you get 3x squared, bringing the power down the front, and then subtracting 1 from the power. Now here, remember, even if it's just a number times x, the x disappears, so it just becomes minus 40. That is the gradient function. And we want to find where that is equal to 8. So that means that 3x squared is equal to 48. X squared is equal to 16, which means that x is equal to plus minus 4, not just 4, coordinates of both points. So you're looking for more than 1. So when x is equal to 4, y is equal to, and you plug it into the original equation to work out y, not the dy dx, that would just give you 8. So 4 cubed is 64, minus 4 lots of 40 is 160 plus 1. 4 equals, now I'm just going to do this the way I do it. So answer squared minus 40, answer plus 1. So that y value is minus 95. And when x is equal to minus 4, y is equal to minus 64 plus 160 plus 1. So it's 160 plus 1 minus 64, which is 97. So my coordinates are, do I have? Yeah, I do. So it's 4 and minus 95. And it is minus 4 and 97. Okay, moving on to question 19. Work out the value of x. Okay, so this looks like my triangles. So this is going to be my sine rule, cosine rule, area of any triangle part of the paper. Here I can also say that is going to be 180 minus 40 minus 62. Because if in doubt, just find anything that's easy. So that's going to be, no, it's not. Not the 4. I don't know where the 4 came from. So that's going to be 78. Then what I can do is I can work out the length of BD. Because I can say that BD over sine 62 is going to be equal to 12.8 over sine 40. These opposite side angle pairs. And I'm using this form because I'm looking for length. So I'll scroll down here. Then BD is just equal to 12.8 sine 62, multiplying both sides by sine 62, all over sine 40. And that will give me an answer, 12.8 sine 62 all over sine 40 gives me, and I'm going to make this, because I want my answer correct to 3 significant figures, I need to make sure this B is correct to at least 4, not 3. If you make it correct to 3, that might introduce a rounding error, which makes you wrong in the final answer. So try and make any answer on the way as precise as possible. So I'll even give it like super precise like that. So that is BD. Then my context clues here are that I have 3 sides and I'm looking for an angle. So that is going to be done from the cosine rule. Now, a reminder, if you cannot remember the rules, is they are given here on your formula sheet. So here we have our sine rule here and our cosine rule. So I'm going to rewrite the cosine rule as given. Now, what you could do is make your life easier by memorizing the rearranged form for cos A. But if you can't, that's fine. You can just, get there from the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos A. And as we plug that in, that means A is always the length opposite the angle you're trying to find. So 17.58237 squared equals 13.4 and 13.4 squared, 15.2 squared. I did not give myself adequate room, but I didn't want to keep scrolling. I'll just rewrite it down here. So a squared equals, now obviously this formatting stuff is not so much an issue in the real thing, but it's just to sort of ease getting it all on the screen. So 17.58237 squared equals 13.4 squared plus 15.2 squared minus 2 times 13.4 times 15.2 cos of the angle, which is x. Okay, so I've got my equation. Now I can solve. So I'm going to square that up. And I'm going to say that's 309.1397. 13.4 squared is 179.56. 15.2 squared is 231.04. 2 times 13.4 times 15.2 is 407.36 cos x. And now I can rearrange. So I'm going to add this across to the other side. I'm going to leave a bit of a break as well, so because otherwise I might get blinded by numbers. So that much cos x is equal to 179.56 plus 231.04 minus 309.1397. And I get on this side 101.4603, which means that cos x is equal to 101.4603 all over 407.36, which gives me a value of 0.249, which means that x is equal to the inverse cos of 0.249, which is 75.6. Because I get 75.57, which rounds to 75.6 to 3 significant figures. I think I should have noted as well, that question was relevant to all syllabuses. Here, work out the perimeter of the shaded segment ABC. Okay. So that angle is 60. This area is 38. That is the radius of the circle. I know that that 38 is equal to the area of the segment minus the area of the triangle. And the area of the segment, is this given in the formula sheet, or do you have to know it? I think you have to know it. Yeah. So the area of the segment is given by what fraction of a circle you're working with. So in this case, you have 60 degrees. So in general, the area would be theta over 360 times the area of a circle. So that fraction of the total circle's area. And an arc length would be equal to this, again, this theta over 360 times 2 pi r. So what fraction of the circumference? So in this case, we have that the area of the sector would be 60 over 360 times pi r squared. So in other words, it's a sixth pi r squared. And the area of the triangle would be given by half AB sine C. So half. Now, again, I'll show you that that comes from here. Area of any triangle, half AB sine C. And so the triangle is a half. Now, the side lengths are R and R. So it's half times R. And then sine 60 in between. Half AB sine C. Now, sine 60 is a special value. Sine 60 is root 3 over 2. So that's a half R squared times root 3 over 2, which combines to give me root 3 over 4 R squared. So what they're telling me is that the area of the shaded segment is 38. So therefore, 38 is equal to the area of the sector minus the area of the triangle. And from this, I can factorize out an R squared and work out the value of the radius. So R squared is equal to 38 over this nasty thing. And therefore, I can find what R is. So 38 over pi over 6 minus root 3 over 4. This R squared would be 419.49. And R is the square root of that, which is 20.48. Again, I want my answer correct to one decimal place, which means my answer, any answer on the way should be at least 2 decimal places to ensure accuracy. So I have my R, and I need to work out the perimeter of the shaded segment. This is a lot of steps. Work out the perimeter of the shaded segment ABC. So in order to do that, I need to work out this length here. And there's an easy way and a hard way to do that. And I need to work out that curved length. So I'll work out the curved length first. Where this curved length is going to be 60 over 360 times 2 pi times that radius of 20.48. And when I plug all that in, that times 2 pi times 60 over 360, I get that that curved length is equal to 21.45. And then the straight length from A to C, I can get from the cosine rule again. And I can say that AC squared is equal to r squared plus r squared. Well, I'll just plug it in. 20.48 squared, 20.48 squared, minus 2 times 20.48 times 20.48 times cos of 60. So 20.48. So answer squared plus answer squared minus 2 answer squared cosine 60. So I get that AC is 4. 9.43. Yeah, it's an equilateral triangle, isn't it? I really should have spotted that. So these are the same length. So in other words, the perimeter of the shaded segment is 24.8 from before, plus the 21.45 for the curved length. And that's 41.93, which gives me 41.9. Now, what I should have spotted is if these are the same length and the angle in between is 60, then the angles in a triangle are 180. If I subtract that 60, I get 120. And because the angles at the base of an isosceles triangle are equal, that means these should both be 60 as well. Which means that this straight length from A to C was also going to be the radius. So I actually didn't need to do this cosine rule at all. I could have saved myself that step. So that would have been the easy way. But even if you didn't spot that, like I showed, you had the cosine rule available in case it helped. Okay, so now going on to question 21. Graph transformations is very, very fun. So, okay, the coordinates of the minimum point are this. You have to know these, and what I find is students really struggle to remember the graph transformations. So just sit down and learn them is my advice. But we have here f of x plus 7 is going to shift everything to the left by 7 units, not to the right. So we're going to take our x and do the opposite. When it's in the bracket with the x, it does the opposite of what you think it will do. When it's on the outside of the bracket affecting y, it does exactly what you think it would do. So this does not add 7 to x, it subtracts 7 from x to make that minus 2 minus 4. And here on the outside, it does exactly what you expect. It subtracts 6 from your y to make it 5 minus 10. And question 22, a histogram. Incomplete histogram, 100 adults ran. All the adults ran at least 5. None ran more than 55. Okay, the thing to note here is that frequency on a histogram is represented by area. So if 14 adults ran between 15 and 20, then this is 14. We know 100 adults ran. So we can kind of count the squares here. So what we say is this column is 5 squares across and 10, 20, 25, 28 squares high. So the total number of little squares in this column is going to be 5 times 28. So I'm going to say 5 times 28 is 140. So therefore 140 squares equals 14 adults. So it means that 10 squares must represent 1 adult. Okay, so then this guy is 5, 10, 15 squares across and 10, 20, 30, 34 squares high. So 15 times 34. Oh, 15 times 34 is 510 squares, which must be 51 adults. And then this bottom one is 5, 10, 15, 20 squares across and 4 squares high. So that's 80 squares, which must be 8 people. But I'll just write that out. So 20 times 4 is 80 squares, which is the same as 8 adults. And then because I'm going to show my working, I'm going to say that 100 minus 14 minus 51 minus 8 is 27 adults left. Um, 27 adults in total. That has to be the area. And then remember, the frequency density is the frequency over the class width. So the frequency is 27. The class width would be 10, going between 5 and 15. Although I suppose, no, in fairness, I actually don't know what the scale is on the frequency density. So what I'll do instead is say 27 adults is 270 squares. And this whole thing is 10 squares wide, so it has to be 27 squares high. Huh, which is the same as before. No, that's 28. That is cheeky, cheeky, cheeky. So this would be 27. And then down. No, lost it. Okay, and the real thing, you would obviously do this with a ruler. I do not have a ruler. So that is what I would draw for the histogram, because that has 270 squares. I'm happy with that. I'll check it later. Right, question 23. Now we're getting to the good stuff. How am I doing on time? Great. So a solid shape is made by removing a hemisphere from a cone, as shown below. In fact, this is giving final question vibes, and yet it's not. I've got several questions left. I got to pick up my pace. Got places to be. So a solid shape is made by removing a hemisphere from a cone. Radius of the hemisphere is 2x. Radius of the base is 5x. Vertical height of the cone is 6x. So we're very much getting into the place where, like, if you're going to get a 9, this is where you're going to earn it. Work out the total surface area of the solid hemisphere. That's insane, because the total surface area of the solid hemisphere that's been removed from the cone. Okay, so let's work out these components. So we know the volume of a cone is a third pi r squared h. The radius of the base, so that would be a third pi. The base of the cone is 5x, all of that squared times the height of the cone, which is 6x. So I can combine all of those numbers and say that 5 squared times 6 divided by 3 is 50. So that would be 50 pi x cubed. The volume of the hemisphere is half the volume of a sphere. The volume of a sphere from the formula book is 4/3 pi r cubed. So dividing that by 2, you're going to get 2/3 pi r cubed is the volume of the hemisphere. So that would be 2/3 pi times the radius of the hemisphere cubed. Now 2 cubed is 8, so that becomes 16/3 pi x cubed. So what this is telling me, therefore, is that 6948 pi is the volume of the cone minus the volume of the hemisphere. So from this, I can cancel out the pi's, and combine this and say that's going to be 50 minus 16 over 3, which is 134 over 3x cubed. I'm going to multiply both sides by 3 and divide both sides by 134. So 6948 times 3 divided by 134 is ugliness. So I get that x cubed is equal to 155.55. And then x is the cube root of that, which is 5.378. So now we want to work out the total surface area of the solid hemisphere that has been removed. So that will be the area of the circular base and the curved area. So I know the curved area of a sphere, if I go back to the formula sheet, would be 4 pi r squared. And so half of that for a hemisphere. So the area, the curved area, well, I'll just say the total area would be pi r squared from the base. And then the total curved area would be 4 pi r squared. So half of that is 2 pi r squared. So the area of the hemisphere is 3 pi r squared, where the radius of the hemisphere is 2x. Sorry, made a little transcription error there. So 3 pi into 2x all squared. So that would be 3 times 4 is 12 pi x squared. So the total area is 12 pi times 5.378 squared. 12 pi times that thing squared is, to the nearest integer, 1090. Okay. 24. Oh, I love polygons. Okay. So the interior angles form an arithmetic sequence. You should note, if you are not iGCSE, turn away now. Arithmetic sequences, that is strictly iGCSE. So it has n sides bigger than 5. Interior angles form an arithmetic sequence. Smallest angle is 84. Well, okay, so what I know is the sum of the interior angles is going to be n minus 2 times 180. And that is going to be the sum of the all n terms of the arithmetic series. So that's going to be equal to n over 2 into 2a plus n minus 1d. So I'm just going to lay that out now. So the smallest angle is 84, so that's going to be a. So 84 times 2 is 168. And the common difference is 4. So 4 lots of n minus 1. This gives me an equation I can solve for m. So that is, I'll multiply the half in. So that's n into 84 plus 2 lots of n minus 1, which is n into 84 plus 2n minus 2, which is n into 82 plus 2n, which is 2n squared plus 82n. And that is going to be equal to 180n minus 360. This gives me a quadratic equation. So by bringing everything to the right-hand side, 82 minus 180 gives me minus 98n, and then plus 360, not making a sign error. I can divide both sides by 2. And that does not look like it's going to be fun to factorize. But I do know it will be factorizable because n has to be a whole number. So I'm looking for them to both be negative, and for them to multiply to 180. So why don't I go through some factor pairs? So we have 1 and 180. We have 2 and 90. We have 3 and 60. We have 4 and 45. We have 5 and thing. This would be going the long way. So I want things. Oh, there, I found it. So 4 and 45. if those are both negative, those would become minus 49. So it'd be n minus 4, n minus 45. And so if you're ever stuck, going through your factor pairs is exactly the way through it. So that means that this is solved by n equals 4 or n equals 45. But we're told at the start of the question, n is bigger than 5. So therefore, n equals 4 is not a solution. And therefore, n is equal to 45. And then we can say that the sum of the interior, because again, whenever you think you're done with the question, reread it to make sure you've got over the line. Here, they want the sum of the interior angles. So the sum would be 45 minus 2 lots of 180. So it's 43 times 180, which is 7740. 7740. And then finally, complete the square on this. First thing I'm going to do is say f of x. I'm going to rewrite it as minus 3x squared plus 12x plus 17. First thing to do when there's a number in front of the x squared is to factorize that out. So that's minus 3 into x squared minus 4x plus the 17. If I divide the plus 12 by minus 3, I'm left with minus 4 in the bracket. So that's minus 3 into, now completing the square on this, you get x minus 2 squared. Subtract that thing squared is minus 4 plus 17. So that would be minus 3. Now I have to remember to multiply the minus 3 into the bracket. So minus 3 into x minus 2 all squared plus 12 plus 17, which is minus 3 into x minus 2 all squared plus 29. So then the answer becomes 29 minus 3 lots. Hold on. So 29 minus 3 lots of x minus 2 all squared. Okay, that's the end of the paper. Now, this is why we're here. We're going to do some checking. First thing to always check, the second you think you're done with the paper, is to make sure you've answered every part of every question. Easy on this thing. Let's make sure there's something on every available number line. Answer line even. So that should be 3n minus 2, 77. Yeah, answer line, answered. Yep. Nope. Well, no, I'll be good. Okay. I've got something there. So 1, 2, 3, 4, 5, 6. Because this is exactly what I would do in the real thing, is make sure there's an answer on every single line. Even though I know I would get the marks for having it there, just for my own mental security, I just want to have that feeling. 60, 90, 2, that 45 over thingy, 2 plus root 5. Yeah, this one didn't have one, which was weird, but I do have an answer. Answer submitted there, and 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 there. So I have answered every part of every question. Now let's get into the checking of it all before I mark it up. Now this is where I think I can really demonstrate some good value. I've been taking some time to talk, but I still have 43 minutes left on the clock. What I'm going to do is I'm going to stop sharing screen, and instead I'm going to share the entire window, because that way you'll be able to see when I bring the calculator in for the checking. So here, what would I do here? I would test my nth term, right? I would test that it predicts things that it should predict. So here, 3n minus 2, let me check that the first term is equal to 1. So 3 times 1 minus 2 does give me the 1 that I need. Let's check my 1, 2, 3, fourth term. So 3 times 4 minus 2 does give me my 10. So this nth term sequence is giving me my terms, so I know it's correct. Here, the 12th term of this sequence, honestly, just plug it in. So 5 times 12 plus 17 does give me my 77, so that's all good. So here, a good way to check your work as well is not to do the same work forwards, but to work backwards or recalculate something a different way. So what I could do, for instance, is in this case, work out how many of the 450 students travel by car. I said the answer was 162. If that's true, then 162 divided by 450 gives me 0.36. And I should make sure the probability left for the bus is half of that, which is 0.18. Or rather, let me divide that by 2 and get 0.18 and add all those together and get 1. So 0.2, 0.18, 0.36, 0.26. It does give me 1, so I know that is correct. Highest common factor of these two. Honestly, the easiest way to do that is just get the fraction and see what they got divided by. So that turns into 2 over 3. So what did I divide by? So 72 became 2. So what did I divide by? 72 divided by 2 is 36. Bam. That's the answer. So coming up with these fun ways to get the answer out using a calculator just to confirm you're correct. So here, for instance, so they drove 82 kilometers. So let's work out what that percentage change is, right? So if it was 82 and it went up to 943, well, the difference would be that. And what's that out of the original? 15%. Which is, so it's 15% more. So the increase out of the original gives me a 15% increase. I recalculated my 15%, so I know my net value is correct. Here, I know that 360 over 5 gives me exterior angles of 772. 180 minus that gives me an interior angle of 108. This one you kind of do just have to recalculate. And then 360 minus that is 156. Great. Expand and simplify. What you can do here, by the way, if you have any algebra, is you can subtract it across an equal 0, right? So in this case, we can say we would expect, if I put anything into m squared minus 3m, and this is kind of for your benefit, minus 40, that would equal this thing. So if I subtract off m plus 5, m minus 8, I should get 0, right? So here, if I type in literally any m, I'll type in 52.94. I'm going to do answer squared minus 3 answer minus 40 minus answer plus 5 answer minus 8, and I should get a clean 0, and I do. So that means I know this is correct. Similarly here, if I got an answer of 9 over 2, let me make this bigger so that just for formatting. What I can do is I can plug my 9 over 2 back into the equation and make sure I get 0. But what I'm going to do is I'm going to rearrange it to get something that should give me 0, right? So here, I'm going to say that 5n plus 6 over 3 minus 3n plus 4 should equal 0. And if I plug in my 9 over 2, so 9 divided by 2, I get 5 answer plus 6 all over 3 minus 3 answer plus 4. Do I get a clean 0? Yes, I do. So I know that's correct. Here, you kind of just, there's not really a way to check this. You kind of just do it. So the members of the set B union C. So all the members of B are there. All the members of C are there. So that's right. Not A, so it's odd, and it's C, so it's the odd multiples of 3, which are those. B intersection C Yes, there are no multiples of 3 in B. Set of D is, so it's not, so there's nothing in D that is in either A or C. And A was, so they have to all be odds, which they are, and they have to not be multiples of 3, which they are. Cool. Not really a good way to check that one, kind of just redoing it. This, there is a good way to check. What we can do here is say if that's the pressure and that's the force, I can rearrange for area. So the force is 84 all over my pressure of 1.12 gives me an area of 75, which I multiply by 21. And I do get my original volume back, so I know my answer is correct. Write this as an order. And I wonder, 3.5 times 10 to the 7. Yeah, it just does it for you. So 3, 5, 1, 2, 3, 4, 5, 6 zeros. I was correct. So 6, 7, 8, 0, 1, 2, 3 plus Argentina's value of 8.2 times 10 to the 5 is that thing. Now, if I want to do that in standard form, this ENG button is a lifesaver because it gets you to the nearest power of, so it would give you 10 to the 3 or 10 to the 6 or 10 to the 9, and you can kind of adjust from there. So I can see it is 7.6 times 10 to the 6, and I am correct. Anything to the 0 is 1. You add the powers and you get y to the 6. 5 cubed is 125. Times a to the 12 times c to the 6, that's correct. Okay, this I'm going to, there's not really a way of doing this other than kind of redoing it. So let me just check that root of 9 squared minus 6 squared is 3 root 5. Plus 9 plus 9 plus 12 is the total length of wood. So the SD button helps you convert between the two. So it's that many, so it would be 37 to the nearest meter, and 37 times 21.5 does give me that many euros. Factorize fully this thing. A way you could do that, I don't really like it. Do you have the equation solver in here? I don't think you do. Do you? Let me check. I've never really used the equation on here. Okay, but you do have an equation solver. Hold on, let me show you what I did. So I went to, nope, not that, shift. No, I didn't do that. What did I do? I went to menu, yeah. So you can go to equation function, polynomial, degree 2, and so it's 6 and minus 5 and minus 4. So x1 is 4, and what you would need to do is you would need to think what factor would that come from? So that would come from x minus 4/3 and multiply the whole thing by 3 to give you 3y minus 4. And the other one is minus a half. So x, that would come from x plus a half, multiply the whole thing by 2 to get 2y plus 1. So that is a way of doing it. I don't like it. What I would prefer is to, again, rearrange this into a form that would give you 0. So 6y squared minus 5y minus 4 minus that bracketed nonsense should give me 0. And if I plug anything into that, so 43.72. Oh, no. This is why I don't deal with silliness. I just like doing calculations. It makes my life easier. So here, for instance, 51.67 equals that. And if I say 6 answer squared minus 5 answer minus 4 minus 2 answer plus 1, 3 answer minus 4, I get a clean 0, so I know that's correct. And same thing here, I can say anything. So 92.84. And I can say, let me zoom in a little bit. I can say 2 answer plus 1 all over 4 answer plus 7 minus 5 answer all over 3 answer, and then subtract off what I get. 31 minus 14 answer all over 12 answer should give me a clean 0, which it does. So I got that right. That's a really good check. Like, find a way to plug something into a calculator that should get you 0. So here, 3 out of 10 were white, 7 out of 10 were black, 5 out of 9 are white on both, 4 out of 9 are black on both. Good. Takes 2 beats of the same color. That's white, white. So let's really just type it back in. Nothing much to it. So it's making sure to use good brackets. So 3 over 10 times 5 over 9 plus 7 over 10 times 4 over 9, 43 over 90. Good. Here, what's a fun way of doing this? Let's work backwards. So if I've said that the savings of Chanda are 6,090, then the savings over here are 1.5 times the 6,090. So this would be B. And this would be 45% more than the savings of Abel. So that would be 1.45 times Abel. So the sum of that would be I'll divide that by 1.45 and get 6,300 for A. And if I add those together, I get 15,000. So I get my original number, so that's good. 15, you can't have 2, that's simple enough. Express the inverse. Okay, so the way I would test for this is to go sort of forwards and backwards. So here, for instance, if I had an x of 6, that would give me, if I zoom in, if I had an x of 6, that would give me a y value of 3 answer plus 1 all over answer minus 2. That would give me that. So if I plug this into my inverse, I should get my 6 back. So 2 answer plus 1 all over answer minus 3. And I get my 6 back, so that is the inverse. Great. 16. Work out the problem. I kind of did check this one by working it out 2 ways and getting the same answer both ways. And this I don't think is too complicated because it really is just typing things into the calculator. I got it the same thing both ways. I'm kind of satisfied with that. Show that this thing, show clear working. Well, it's easy enough to show that I got the right answer, but that's the reason why they say you have to show clear working, is they don't want you to just type it in and get the answer. This is a good way to check that you got the right answer, but they want to see the steps there. So here, find the coordinates of both points. Well, there's 2 things to check. First, do the points that I found actually lie on this curve? Second, do they actually have a gradient of 8? Actually, I'll check that first. So dy dx, I have definitely done correctly. Actually, let me show you something really cheeky. So here, if I do shift this button, you can differentiate x cubed minus 40x plus 1 at the point where x is equal to 4, and it does equal 8. And I can do it at minus 4, and that also equals 8. So I know both of these points have the right gradient. From there, do I know that they both lie on the curve? Well, what I can do is say 4 equals, and then do answer cubed minus 40 answer plus 1. And I get minus 95 when x is equal to 4. Well, let me move that over here. So, yep, minus 95 when x is equal to 4. And then when x is equal to minus 4, then answer cubed minus 40 answer plus 1 gives me 97. So yes, they both lie on the curve. So I feel good about that. Here's a quadrilateral. Work out the value of x. So what I will do is I'll just work backwards to make sure I get everything right. So if I have my x as being 75.6 degrees, I'm going to work the other direction. So if I plug that into here, I would get a squared is equal to b squared plus c squared minus 2b c, lots of cos 75.6. So that gives me that squared. Square root should give me that length. And then what I'll say is that length over sine 62 is meant to be equal to 12.8 over sine 40. So here I should get a number very close to 0. And I do. So that means I'm right. Because that's times 10 to the minus 3. So it's 0.005. So that small error is due to the fact that I used a rounded value of x. If I had used the precise value, I would have got a clean 0 there. So again, finding ways to work backwards or show you get a clean 0, good way to go. So here, there's not really a good way to work backwards here. So what I'll do instead is check that my value of r is correct. So I'll work backwards for my r. How did I get my r? Yeah, I can work backwards and get this 38 back. Because this 38, well, let me first check if that r is correct. That should be 60, so that should also be r. And then 6. Let me check the out. So 60 over 360 times 2 pi. So this all depends on my r, which I've said is 20.48. It's that thing plus the 20.48 means the perimeter of my thing is, let me read the question again. Work out the perimeter of that shaded segment. Yep. So that I said the perimeter is 41.9. Yes. So if my r is correct, then my answer is correct. Let me confirm that my r is correct by saying 60 over 360 times, well, actually, let me put I said my radius was 20.48. So I'm going to put that in as my answer. So that's now stored as r. So I'm going to say that 60 over 360. So that much of pi r squared minus the area of the triangle, which would be a half a b sine 60, does give you my 38 back. So I feel good about that being my answer here. Curve 21, this you just do it. So 5 minus 7 is, well, I mean, if you really need me to, I'm going to do it. So 5 minus 7 does in fact give me minus 2. And then on the second one, I'm knocking 6 off from the minus 4. So minus 4 minus 6 is equal to minus 10. What I'm going to do here is work forwards and make sure I get an answer of 100. So if that, so I'm correct that that is 10, 25, 6, 7, 28. So 28 times 5 is 140. So 140 squares is equal to 14 people. That's correct. So then what I would need to do is to work out the total number of squares if what I've done is correct. So 10, 10, 20, 25, 26, 27. So 10 times 27 plus 5 times 28 plus 15 times 10, 20, 34 plus 20 times 4 and divide by 10 does give me my 100 adults, so I feel good about this histogram. So you see, never doing exactly the same thing, just checking it a different way. So here, working out the total surface area of the solid hemisphere that's been removed. I like what I did here in that it's the circle pi r squared plus half of the 4 pi r squared, which is 2 pi r squared. Add those together for 3 pi r squared. And the radius of that thing is 2x. So this really all hinges on x being correct. So if my x is correct, 5.378, then my radius of the hemisphere is twice that. And then my curved area would be 3 pi times that squared, which is 1090. So if my x is correct, then my area is correct. Now, is my x correct? I'm going to plug it back in and make sure I get the right volume. So if my x is 5.378, then the volume of the cone, which is a third times pi times the radius of the cone, which is 5 answer squared, times the height of the cone, which is 6 answer. And I subtract off from that the volume of the hemisphere, which is going to be 2/3 pi times the radius of the hemisphere cubed. I should get something close to 69848 pi. Good, that is close. Especially for how big the numbers are, that's very, very close. So I feel good about my answer here. Here, polygon has n sides. This is going to be quite simple. I'm going to say if n equals 45. So again, 45 minus 2 times 180. So that would be the sum of the interior angles. Now, if I plug my 45 back in, do I get this? So the sum of the interior angles would be 7, 740. Would the sum of the arithmetic series be 7, 740? Well, it would be n over 2 into 2a plus n minus 1 d. And that also gets me my 7, 740. So I feel good about that. And finally, you know what I'm going to do? I'm just going to rearrange this into a form that would get me a clean 0. So here, the form that would get me a clean 0 would be 17 minus 3x squared plus 12x, and then adding this to the other side, I would get plus 3x minus 2 all squared minus 29. That should give me a clean 0, 81.27. 17 minus 3 answer squared plus 12 answer plus 3 lots of answer minus 2 all squared minus 29, clean 0. So that's correct. So those hopefully are some nice creative ways that you can see to check your work if you have time. In this case, I did. And in fact, I still have 18 minutes on the clock, especially if you have extra time and are good at the math. So for instance, people who have dyslexia, um, then you might find that you're kind of fine on time. Um, that is a good way to sort of check your work. If you find you do not have enough time to check your work, maybe checking, you can still use those skills to check on the way, like I did with that probability. If you're feeling insecure about an answer, you can kind of plug it into the calculator then and there, just so you feel a bit more secure. Right, now I'm going to mark it just to make sure I didn't do any silliness and leave you with any silly answers. So I've got my mark scheme. How am I gonna... Well, in fact, hold on. What I should have done is make this half and half. So if I, whoop, okay. So if I share screen again, entire screen, so I can fit both. We have mark scheme here on the right. So you can see what you need to see. And I'll have my answers here on the left. So 3n minus 2 is correct. 77 is correct. 162 is correct. 36, yep. 820, yep. 156, good. M squared minus 3m minus 40, 9 over 2. Fractions are your friends. Okay, let's check I didn't do anything silly here. 23, 24, 27, 29, 30, 31, 33. I could have made it easier for them by writing it in size order. Yes, there are no multiples of 3 in set B, so none of those are divisible by 3. Good. 23, 25, 29, 31. Good. 1.12. 35 with 6 zeros. Good. 7.6 times 10 to the 6. Good. 16125 A12C6. Good. 795.5. Good. 2y plus 1, 3y minus 4. 31 minus 14x all over 12x. 3 tenths and 7 tenths. And then 5 ninths, 4 ninths, 5 ninths, 4 ninths. Good. The area, the probability is 43 over 90. This is 60, 90. This is 2. 1 plus 2x over x minus 3. 45 over 76. 2 plus 5. Now, this is a show that, so they really want to see every step of the working here, which I did show, but they look how detailed they are about what exactly they want to see from you to make sure you didn't just type it into the calculator. So a show that, show every step of your working, really check the mark schemes to make sure you're not skipping any steps. Even if you're sort of clever enough that you can do it in your head or you could do multiple steps in one go, don't. Act as if you are teaching the examiner. Act as if they are a student who will not understand unless you are explaining yourself very carefully. And show every single step so as not to confuse them. Makes it much easier for them to give you the marks you deserve. Okay. Now, moving on. So we get 4 and 95 and minus 4 at 97. Here, 75.6 degrees, 41.9, minus 2, minus 4, and 5 minus 10. Histogram, what are they asking for here? Yeah, 27 people. Correct height of bar at 2.7, good, and correct width. Yes. Then here, 1090 is correct. And here, 740 is correct. And here, 29 minus 3 lots of x minus 2 all squared. Good. Everything correct, as well it should be. For someone who does A-level math, I would hope to get 100% on a GCSE paper. So hopefully you find that useful. Let me just bring you around here so I can talk to you guys. Right. So hopefully you found that useful. In particular, pay very close attention to that checking technique. That is something I do not see a lot of teachers teaching because they frankly don't have the time. So I'm glad to sort of step in and give you that exam technique. Now, as long as we're talking about exam technique, let's talk grade boundaries. So if you're doing iGCSE, which is the one I'm most familiar with my students, if you're aiming for, you can kind of see where people are going to score based on where they're struggling the most with their questions. So if you are struggling on questions like sort of 10 to 15, that to me looks like a 6. If you're struggling on 15 to 20, that's level 7. If you're struggling on 20 to 25, that feels like a level 8. And if you're able to answer the questions through to the end, that's a level 9. So they kind of get progressively harder as you move through the paper. Now, what I would do, if depending on your level where you're finding difficulty, never ever just give up on a question. Even if it's a 5 marker where you know you have no chance of getting all the way to the end, look for one step you can do. Prove one skill you do have with what's given. Like, oh, I can't do all of that, but I can, I don't know, work out I could do Pythagoras to work out the height of that triangle. Even if I can't do any other step, just show them what you can do, and chances are you'll be able to pick up a method mark. And I call that method mark hacking. So rather than leaving a questions entirely blank, use even if you don't know if the skill is correct or in any way relevant, show them you have the skill, because there's a decent chance you pick up enough method marks to put you over the edge. Also, if you know you're going for a 7 and the questions at the back are just sort of not going to work for you, it means you can actually kind of, if you know you're not going to get them, you can use that time to go back and check your work to make sure you didn't make any silly mistakes on the way. So you actually get all of the marks you deserve on questions 1 to 15. So depending on what your grade you're targeting, you can allocate more or less of your time. Rather than spending half an hour on question 25 and getting no marks for it, you could use that half hour to check your work, plug your answers back in. Because even if you conceptually understood it, because there's 3 types of mistakes in a math paper. There's conceptual issues where you just don't understand how to do the math, like which might be with some of those end questions. But there's also execution errors where you know how to do the math, but it just comes out wrong. So that might be a classic sign error, moving something across the equal sign and forgetting to change the sign of it. Things like that. And that's what good checking can pick up. So use some time available to run your answers back in, make sure you haven't made any execution errors. And if you check it and you see that it isn't right, it lets you know, okay, let me redo this. Let me pay very close attention to make sure I've executed every line correctly, spot your mistake, pick up those marks where you deserve them. Also, 2 pieces of important exam technique for any math paper. The second you think you're done with a question, reread it to make sure you've actually got across the finish line. So that might be something like, I solved for x. Well, it didn't want x. It wanted you to keep going and get this final answer. It wanted you to plug x back in to find something else. Or maybe it asked for it to be quoted in a very specific way. So it wanted it to the nearest integer, not like 21.7, something like that. You should also look at how I did my rounding on the root. So if you want an answer correct to 3 significant figures, any answer on the way has to be correct to at least 4 significant figures. And finally, when you think you are done with a paper, make sure you have answered every part of every question, because it's easier than you think to miss a part of a question. You think it sounds silly, but when you're the one who does it, it feels even sillier. And so don't be that person. Check to make sure. Right. So hopefully you found that useful. I may do the second paper of that series as well, just to round it out, just in case people find that useful. But in the meantime, enjoy your GCSEs, enjoy your summer, get into the A levels, and then when we get into the sort of A levels and university admissions, you might find me a lot more useful. But if you guys find this useful when it comes to the GCSE, I might put out more of this content as well. So do the YouTube things. If you engage with it, I'll do more of it. You know the rules. Like, YouTube is not new at this point. You know what to do. So with that, I'm going to leave you. I'll get another one done on that. In the meantime, for all my regulars, I should have an A-level live solve done Monday morning. So I'll see you guys then. But in the meantime, work hard, take care, and I'll see you next time. All right, bye-bye.